Welcome, everyone. Last speaker of the day. My name's Tom Carlier. I'm a senior software engineer at Tripwire, and I plan to talk a little bit about continuous integration, pipeline configuration, and some other automation tools. Now, if you're a little bit like me, you got two things on your mind right now. Who is this guy, and why should I stick around on Friday afternoon and hear what he has to say? So let's tackle that right up front. Back around the turn of the century, I took a job in what was considered the mailroom at Informix Software. Effectively, I was that guy that was in the presentation, the keynote talk this morning with the hard hat on, the build meister, the build maestro, as I like to call it, or the build engineer, or the build guru. I got called all kinds of names. From that point, we typically pay our dues in the build room for a little bit, and then we move on up the corporate ladder to be developers and programmers and QA and CTOs and all those other interesting things. I took a little different path. If we fast forward to today, I'm still there in the mailroom. I did, however, go and further my education by taking some night courses in software engineering. And now I've got a degree in mailroomology. So that's who I am. Of course, a lot has changed in the mailroom since I started. I don't know if any of you have ever witnessed one of those team meetings where you decide if you're going to do the build on Thursday or if you're going to do the build on Friday, but I was in several of those painful meetings that often had 30 or 40 people in them just to decide if you're going to do the build on Thursday or if you're going to do the build on Friday. And as you might guess, development was really, really slow at that time. Then, of course, we progressed into nightly everything, which is really scripted everything, and that speeded things up a whole bunch. But now we're kind of fast forwarded to today, and we have what I like to call continuous everything. I was inspired by continuous integration. I look at continuous deploy, continuous test, continuous release, all those continuous disses and continuous DATs as an extension of the continuous integration, basically the application of the theories of continuous integration that were written about by Martin Fowler across all of the disciplines of the system development lifecycle. So we're a whole bunch faster. Back in about 2010, I took a job at Tripwire Software in the mailroom. At that time, Tripwire was a small startup company, a small team, single product. Venture capitalists were getting antsy to get their money out of it. They were thinking IPO, and they've changed a lot since then. They are today what I would call an enterprise software shop. We've got multiple products, multiple builds, thousands of configurations in our CI server. And if you can help me out here, you could maybe tell me what's wrong with this picture. Right? 2 SCM engineers. Companies growing like gangbusters, right? And they still only have 2 SCM engineers. And SCM, by the way, to me is software configuration management, not systems configuration management or security configuration management. All those people that use those are just trying to steal my acronym. But now I could, if I wanted to, I could put on my JFrog colored glasses. Anybody here an alumni from last year? If you were, you might recognize these. It was one of the handouts we got. But I would look at this here and I'd say, what's right with this picture? And the answer, of course, is the same. Whole company's growing like gangbusters, and I didn't need to grow the SCM team. That's why you might want to stick around on Friday afternoon of a 3-day weekend to hear what I have to say. Hopefully, I'll make it worth your while. So starting out at Tripwire as a startup, it was a pretty small build process. It had about 40-some builds. I used to use Microsoft Project to put the pipeline together and use critical path analysis to figure out where to put the hardware, because we were a poor company with not very much money, and we couldn't do like Google does and just throw resources at everything. We had to dole them out very carefully where they were needed. Today, our build dependency graph looks like this, and I'll use the term dependency graph, dependency tree, dependency pipeline, all synonymously. Basically, you take this, the build dependency tree, and you flop it on its side, and that's your pipeline. Kind of looks like a ship, right? Or do we have any sailboat fans here that think that looks like a sailboat? I like to call it a ship, so don't be offended if you're a sailboat guy. Back again to 2010, when I first started, here was our dependency resolution process. This was our build pattern. We had stuff all over the place. We had it in Subversion. We had libraries in an Ivy repo. We had third-party libraries checked into the code. We had Team City snapshot builds passing stuff between builds. They were tightly coupled together. And I proposed, and they accepted, a very simplified build dependency process. And this should be Build Engineering 101 for any of you who have been continuous integration environment. It's an input, it's some processing, it's some output. I like to design everything in the abstract form, so I didn't put GitHub, Team City, and Artifactory on there. But if you must know, because everyone wants to know, that's what we mostly had. Actually, that's mostly what we have today. So in 2010, that's when Artifactory came to Tripwire. We started with about version 2.1. And so I've been with Artifactory longer than most of the people at JFrog. Now that pattern, it scales up, right? You have library builds, you have component builds, you have installer builds, you end with a release build. This is a simplified version of a scalable build pattern the way it looks. If we take that, collapse it horizontally, we get my favorite notation for it, which is this. I use a shadow to show multiple instances. In our Tripwire Enterprise, this line is 550 times long. There are 550 builds in our build dependency tree. Every one of these boxes, effectively, is one of those builds. If we take this build pattern, collapse it the other way, we get this ship-looking thing. So I like to start there by just setting the stage for this is how I talk about these things. This is how I like my notation to be. So I know it's Build Engineering 101, but from this point forward, we'll hopefully go a little bit deeper. Getting anywhere as an SCM engineer requires cooperation of the development team. So I wanted to implement this abstract build pattern, and I needed a partnership with the development team, and I got together a bunch of senior developers to work with us. The first thing I needed is I had to have this dependency graph automatically generated, as opposed to me sitting and manually creating it in Microsoft Project. That takes forever. You can do that with 46. You can't do it with 550. So I needed a little bit of a build pattern that had unique IDs, and then I did something called publishing the dependencies. You have to capture the build dependencies that were used in a build at build time if you want to know exactly what they were for that particular build. This turned out to be pretty easy. We were a Gradle shop. We were switching to Gradle. Gradle has a project reports plugin, and we take the project reports plugin, run that at build time, and then publish the dependencies.txt as a classifier artifact into the Artifactory along with the artifact we were publishing. So our standard was Maven artifact publishing, and you must have a report showing your dependencies published along with that up in the Artifactory. Couldn't have done this without the Artifactory. So what does that look like in my notation form? Top line is the actual build. 100% of what happens after is an aggregation of all those dependency reports to make an aggregated dependency report that I can show to whoever wanted to see it. Effectively, that was a textual view of that ship. And so it would look something like this with things that you can click on and expand and look down, basic, simple, easy to understand HTML documentation that tells you how many Tripwire artifacts we have, how many third-party artifacts are in that build tree. And so that's the entire dependency tree all rolled up into one aggregated report. That was my first thing. Second of 7, if you want to follow along, we're up to number 2 of 7, was a change report, because if you're a build engineer, a build maestro, and you're the first pass at triaging broken builds, you must be able to tell what changed. You can tell what changed by doing a build output diff report, but you can tell what changed by doing a build input diff report. And X-ray is a really cool tool, but it does a build output diff report as I would think about it. It tells you what's inside of that package, but it doesn't tell you who changed it and why. So my change report needed to be a build input side change report. That meant I needed a single traceable source from every build back to the GitHub repository, or at the time some of it was Subversion, some was Bazaar. And I don't mean Bazaar in a bizarre way, I mean Bazaar, the source code server, Bazaar. So the change report became a simple game of comparing two ships. What changed, and producing reports that showed how many of each module of those, at this time of this report, was over 1,000 different components, 1,000 different, 500 different builds. And we can tell the details of each source change report. Basically, we're taking every source that changed. In this case, it was 207 of them changed. This was a diff between release A and release B. These are the files that changed in this source, and these are the commit messages. So effectively, we've done 550 diffs potentially. In this case, we only had to do a few. Aggregated them all into one report so that you have one-stop shopping and you can tell what changed in a very highly modular build development environment. Third thing we needed was release tagging. Tripwire supports multiple back versions, sometimes years old. So we have a policy where we want to keep everything reproducible, and to keep everything reproducible, we need to have the exact third-party libraries that were used to build it. So we have to be able to go and tag those and know what they are in the Artifactory. We use the Artifactory properties for that. But to do that, we have to have all of the third-party libraries in that local repository. We certainly can't go out and tag things in Maven Central. We certainly can't guarantee that a third-party library that's in Maven Central today is going to be there tomorrow. So we have to pull that down locally and be able to tag it and say, this is what we built from. This was kind of tough because this is what our build environment looks like. Our build agents are blocked from going to the internet. That works really good both ways. Keeps the internet away from our build machines. Our security team really likes that. We also don't allow our builds to use remote repos, even though we have them. The automated build user is not allowed to use them. So effectively, there's a firewall between the Artifactory and the internet, meaning the only way those builds are going to succeed is if everything is in-house. That forces it to all be in-house. Developers are allowed to use the remote repositories in the Artifactory to pull things down from Maven Central, but then we have them copy them from the remote repository cache over into a local repository where we can tag it and keep it around for as long as we want to keep it around. That leads into the next automation project that came up, and that's selective artifact cleanup. I came here last year, and I was very much shocked at someone describing the $1 million artifact problem and not having a way to clean it up because the developers wouldn't allow them to take anything out of there because you take the wrong thing out, builds break, and they can't rebuild. So we have to tag them to be able to do selective cleanup. We also had to have a unique ID that was a sortable artifact ID. If you're following this along, what we're doing here is we're shaping that abstract build pattern. It's just getting a little bit more robust, and it's getting fleshed out to require a few more things from the developers. But when they do it, it's automatic. We have our artifactory. It's all loaded up with artifacts. We keep the latest ones, which is effectively the latest ship, and we delete everything else. And then you're down to just the ships in the artifactory. And so we're a lean machine when it comes to the storage space that our artifactory takes up, and that saves us a few dollars. And that's what we need because we're a company that doesn't like to spend a lot of money. Now, if we move along, I'm trying to move this along fast because I know you all want to get home. It's Friday afternoon on a 3-day weekend. My legal guys got a hold of this. That's what really catapulted it from a nearly skunkworks project to the level of executives know this is going on. And they know about this because this identifies all the third-party libraries that are in every release build that ships, or were pulled down to use to build it or to use to test it, at least as far as the tests that are under my SEM control, which is basic acceptance testing, but not the full system testing or performance testing that happens somewhere else. I'm trying to get them to adopt this so that they can do the same thing. But this third-party approval then means we have this list of all these artifacts, but we can't tell what's shipped and what's not shipped, and that's really important when it comes to meeting our legal obligations. So what we have the developers do, because that's ultimately who you have to go to sometimes to figure out what's happening with a third-party library. They pull it down, but what are they doing with it? And so we have them pull it down with a scope that matches a certain convention, and based on that naming convention of the scope, it's a key to whether it's shipped or not shipped. So our reports all of a sudden have what's shipped and what's not shipped. And those reports will look something like this, where we're comparing 3 or 4 releases back, a third-party library artifact. We're setting properties in Artifactory to indicate whether it's been approved for shipping or approved for build only, approved for test only, what's its license type. And in this case, we use the most restrictive license type because some third-party libraries have multiple license types, and we like to know what's the most restrictive. And then, are they still in it? Were they dropped? You can see that the third one down on the list was dropped after release 8.5.2. This is another thing that this is the thing that actually sold Tripwire, the company, from a private venture firm to Belden Cable without going through an extremely expensive vulnerability scan of the source code. Our process has such good control and such good visibility of what's in it that it moved up the closing date considerably. So the next thing, of course, since we're kind of on this legal thing, is you have to do escrow kits to make, for some of our customers, for a lot of our customers, and we wanted to automate that. So with all of this traceability going on, all we needed to do was make sure that we had traceable build configurations. And then after our builds run on the top line, that 550 builds or more, we run an escrow kit builder that's traceable to the source, traceable to each artifact configuration, and traceable to the artifact in the Artifactory. And voila, we've got an escrow kit for every product. So from there, we went to the culmination of this, number 7, which is my favorite. It's the CI pipeline configurator. I didn't even know what I was doing when I made it. All I was is tired of one of our managers showing up in my cube every so often saying my developer committed a build. It was a QA manager at the time. A developer is insisting that he checked in the fix and it's not coming out in my build. How come? And usually it meant that a Team City trigger was not in place. So I put together this thing called a trigger validation script, and I needed one more piece of information, which was the constraint string used to pull down that artifact. Was it dynamic or was it fixed? If it's dynamic, I want to trigger. If it's fixed, I don't want to trigger. So by adding that to the published report from each build, I can now match up all of the triggers that are needed with all of the triggers that actually exist and produce a report that showed what needed to be added and what needed to be taken away. From there, it was just a simple matter of saying, why am I getting a report that says add these triggers and remove these triggers? Just use the API in TeamCity and make those triggers happen automatically. And so through the last 3 years, I haven't made any manual triggers. They all happen automated. And that's kind of my cool thing. I was here at swampUP last year, and I had what we call at Tripwire an aha moment in honor of our founder, Gene Kim, who constantly said, holy crap, every time something surprised him. And here I was, I'm saying, holy crap, what have I done? I got this configuration pipeline configurator that's automatically changing my pipeline as the builds change. Now this fits into the talk that we had this morning at the keynote speaker about hardware. The interesting thing about hardware is if we were Ford Motor Company pumping out cars, it's good enough for us to reconfigure and retool our pipeline once a year for the new model for that year. In software, we don't ever make the same thing twice. Every build is new. Every build is a prototype, so to speak. Therefore, we need to possibly be retooling every time we do a build. And to retool every time we need a build means that it needs to be updated and following what the developers do. So the developers have an abstract build pattern to follow, but in exchange for following that abstract build pattern, all these other things just happen automatically. Our SCM team stays at 2 instead of growing like it would normally. That means that managers come to me and they say, you need another guy? No, don't you need another developer? So we have more developers because I'm able to keep the SCM team small. And so then I looked at that mailroom again and I said, well, where are we? Where exactly does this fit in this board here? And I have to say the aha moment was, hey, maybe we've gone from fast to even faster because right now what we need and what we should be working on is self-configuring everything. We should not be manually creating and configuring pipelines. I'm following the developers around, and when they make a change to a dependency or when they add a dependency or take a dependency away, the pipeline is automatically molding and changing with what that developer did automatically. I actually run it within a day, so it's not quite continuous, but it's pretty close to it. It's an expensive process, but it has to go and pull all the build configs and examine all of the triggers for the whole entire tree. And I looked at one last week that has over 2,400 dependencies in it. And we have about 6 products now that are over 1,000 artifacts in their dependency tree. They've gone from pure Maven to now having Docker and Python and NPM, soon to have Yum as its own separate thing and more to come. Just looking at what JFrog is doing with Artifactory, I'm migrating from Artifactory 4 and changing my pattern to where I'm separating that artifact ID from its location. In Maven, they're the same. They have to be separate for these other different technologies. It's been an incredible year standing up Artifactory and modifying my tools to work with all these different technologies. And so I got 4 done just recently, and this week actually we're shipping one of the first products that is a Docker-based product. And it's a Docker-based product that is publishing these reports and has self-configuring build integration pipeline. So we're a little faster. What's next? This is the where do we go from here? A little review. We've got these builds. After the build happens, we aggregate these reports. Another way to look at that, or another way to work with this, is to throw away that publish and parse. And I know a lot of VI guys are here, right? Did you ever go to a social event where the VI guys were kind of competing with each other to see who's the better VI guy or who's the better regex guy, right? So I once saw these two guys, I'll call them John and Keith, just to protect the innocent or the guilty, whatever they are. But John says to Keith at one of these events, he says, what happens if I type :26, comma, / top, / echo space, / G? And Keith says, oh, that's easy, nothing. And John looks at him, oh, and then push enter. And Keith says, oh, you just prepended echo to the beginning of lines 26 to the end of the file, but what did you put that G there for? That does nothing in this case. The beginning of the line can never repeat itself. So from there it escalated, and for 2 hours I listened to these two regex guys go at it. Fortunately, we're changing so that it's not so regex-centric, but that publishing of a Gradle dependency report in its text format and trying to parse that out in the face of builds that are Gradle builds that are growing bigger and having multiple sub-projects underneath the same one, and sometimes those sub-projects publish and sometimes they don't publish. But the dependencies of the ones that don't publish but are consumed internally need to be pulled over up to the top level. So it's been a challenge. What we've done now is take that Gradle plugin that publishes a report, and we've modified it to push into an API, a very simple LAMP stack application with a dependency graph in a database and a REST API on top of it. And we're calling this our Build Dependency Management Server. We're just currently switching over from what I call the buffet style publish and parse reporting to the a la carte dynamic at build time, push those dependencies straight in. So no more publish and parse, no more crazy regex to figure it out. Just simply push those into a database, and from there we can do all kinds of stuff. So we'll be taking effectively this scenario, which is a taller version of our build pattern, and all of our different types of builds that produce reports that are parsed and used by all of these tools. And we're changing that to where all of those tools will have their own API that'll push into this database. And what we have is a build pipeline that's a first-class entity. It's no longer just something that exists. We have it now in a database where we can manage it, think about it, query on it, and learn. And the list of tools that we're going to do with this is pretty crazy long. We'll be able to do even more selective artifact cleanup. We'll be able to tell in a multi-build view where every third-party library is. And I haven't really mentioned it too much yet, but the Escrow kit build script is also the same script that takes all the sources, all the third-party libraries and all the sources, and puts them on our vulnerability scanning server so it can scan them. All of this is stuff that's real easy in the old monolithic days, and this is how we've adapted to modular. Now we just build what needs to be built. As I said, we're not the kind of shop that builds everything every time. We support legacy builds on some very slow building architecture, and so we can't be, not without being crazy slow. So that leaves me to my last slide here is where is all this going? Or what is going to happen with this build dependency management server? I was hoping to say, I've got approval to open source it. You can go download it. You can download the plugin. You can put it in place, and you can use it. Unfortunately, my request for open sourcing is tied up behind a whole bunch of legal obligations because Tripwire has two first ever releases of 2 new products coming out this month. And legal has been tied up with approving all of the third-party libraries and getting everything in place to meet those requirements. So that may be coming soon. Maybe I'll be back here next year. You can email me and I can tell you when it's open sourced, or you can watch for it. Or you can say, hey, this is JFrog. JFrog is adding support for the build dependency graph into X-Ray. And so this week I have downloaded and started looking at JFrog X-Ray, which I would have done back in August when it first came out as an on-prem distribution. I can't use the cloud because we're a security company. We can't put our code out there. Our model, our leadership won't let us do that. And when I came to swampUP last year, I heard that X-Ray was hosted only, which it was at that time, but I never caught that it was going to be on-prem, or I would have been jumping on it in August. But that's water over the falls now. I'm looking at it because it has in its February, I think, the February release notes, it says that build dependency graph is supported. We saw a little bit of that in some of the other presentations. What we really need is a place to store and hold and track and query against that build dependency graph. And so maybe we'll switch from our custom, which we're not in that business of wanting to build CI tools. We build security software. We would much rather have someone like JFrog build the product that works, that we can use, where we can push all our build dependency information and then query it and sort it out whichever way we want to. And with that, I got to give you that standard reminder, fill out the card, take any questions, tell you about my personal blog, scmisSDLC.com, if you want to follow along there. When I do get permission to open source this dependency manager server, that'll be where I'll say it. Or if I decide, hey, we're going to go with X-Ray, that's where I'll say it. Or you can email me at tcarlier@tripwire.com.
Questions or?
Yes?
What kind of branching scheme do you use? Are you just using master, or you use something like Escrow?
So that's a good question because we have a lot of developers and a lot of projects and a lot of different ideas about what's the best way to branch. I don't know if you've ever met a developer that didn't have an opinion about what branching model you should use. I've been at it long enough to know that they're all the same. After a while, they just all start to look the same. There is forward rolling release branching, and there is inverted branch by release. We have kind of a custom branching model for some things. The one that is right depends on which component you're building. If you can get away with building only on master and doing the rolling release, that is absolutely the best way to go. Don't branch if you don't need to. When you get up to the top level, at the very highest release level, now you're talking about something that is likely to need concurrent work. And if it's likely to need concurrent work, it's a lot less work to branch it early than it is to branch it late. Or branch it as needed. If you know you're going to need it for sure, it doesn't really matter when. Plus, we also have GitHub teams using the Git flow, where we have a dev branch that's building in Team City and a release branch that's building, which is actually master. Our unique build ID includes the branch. So we can go into Artifactory and grab all of the artifacts and sort them by branch and know which one's the latest on each branch. It's a rather interesting artifact string that's been around for a long time. If you must know, it's major, minor, patch, micro, branch, timestamp, revision timestamp, revision hash, and then the build number. And if you think about it hierarchically, that's kind of the hierarchy of how your build artifacts should start falling out. Your major, your minor, your patch, your micro. But they can span branches at that point. And so we had to put the branch in there. That was a really tough decision. Some people don't like it, some developers don't like it, but it has to be there in order to differentiate what's happening on master and what's happening on the dev branch, or what's happening on the feature branch, because they'll all be the same major, minor, patch, micro. Micro is usually not shown, but it's an implied 0 in the way we look at it.
What we've done to kind of get that view is separate repositories for virtual repo that aggregate them together. So we have like a dev repo, there's an RC repo, and a release repo.
Mm-hmm.
We have a virtual repo to aggregate them together. We use IDs, so we use -dev for dev, -rc, so IB understands that anything that's -dev is less than -rc, and anything without the dash call release.
Right. We're not a pure Ivy or Maven or Gradle shop anymore. So we have Docker, which is very challenging because that's just a container. It's a named version container. It doesn't have an organization. So we don't have that element, but we just put Docker in there, so we plug it. It's either Docker for third party or Tripwire Docker for a Tripwire Docker. What we do is we've actually gone to a kind of a modified forward branch by release model, but we don't cut the branch until code freeze. So we're basically working our top level main release on master, and then at code freeze, when we're pretty close, is we'll cut a branch at just the top levels, maybe 2 or 3 levels, maybe the installer level and the release bundle level. And after we make that branch, then all the pinning happens there. And they'll lock it down as static. And then the next release work will continue on master branch. We have some projects using the semver, the semantic versioning. It's really a hard one in our environment. Semantic versioning doesn't support concurrent development very well. It supports forward rolling release in a limited amount. Other questions?
How did you convince some of the developers to change the way they were working in order to give you some of these deliverables?
That's a tough one. I have had a group that I call my SCM Interfaces Work Group, which is pulling together some of the leaders from all of the different projects and putting them together in a room and saying, here's what I propose, here's what we'll get from it, will you agree to it? And some of those have gone good and some haven't. Newer developers coming in, yes, they're very often going to come into Tripwire and start and say, whoa, that's a little bit overwhelming. But they don't have to be very involved in the legal process of, I mean, they have to request approval for every third-party library that they add, but they're not, as long as they follow the abstract build pattern and all of its rules for traceability, all this other stuff comes with it. And I keep telling people that if I'm selfish, it's good for everyone. And they look at me kind of funny. But if it's easy for me in SCM, the rest of the team benefits. So if we have traceability by convention and not by lookup, we set that early on. The leaders agreed to it, and so the senior leadership has to agree to it and then impress that up downward onto everybody else. It's a struggle to keep them on board. At times, it's so easy and so nice, and some developers are just like, yeah, I get it. But there are times when there are developers who are not so willing to do it. But in the end, they want to release their code. The biggest part of this is legal. And so my legal team demanding these reports means that I have to now demand that they follow this build pattern so that the reports work. And so there's a lot of leverage there because it's so ingrained now into our process. So many people are relying on it. We're enterprise. In the startup, you don't have to worry about things like getting sued for patent infringement because you've never released and nobody's seen your code. You don't have to worry about supporting 15-year-old versions of TM, TFS on platforms, on OS platforms that have lost their support 10 years ago. We have all those needs to be able to support that, and this is how we're able to do it. This is how we're able to confidently know that our Artifactory has everything we need to reproduce all of those older builds. So they get a lot from this. At escalation time, all their stuff is there. They're able to build it. There's a few glitches. Most of those glitches will go away once we switch to the database. We forget to tag a release. Some things disappear. We have to recover them. But we actually don't delete them at first. We push them into what I call a trash repo, which is really a recycle bin, and they sit there for 3 weeks before they're deleted. So nothing is deleted within 6 weeks of when it's built because it won't be trashed if it's been built within 3 weeks. So we have a 6-week window to figure out that something was deleted that was needed. So there are benefits to the developers. We could fill this Artifactory up with 1 million artifacts, and then it would run so slow there'd be intermittent issues every time they're trying to download something. They've come to rely on the Artifactory. It's so critical now. We'll probably be looking at multiple Artifactories and distributing the load just because Docker is so big, and we can kind of start to tell somebody's building Docker and it's uploading or downloading a Docker container, and those things are so huge. We're also, one of the companies that we bought is also an appliance company that was Encircle, and so our IP360 offering is an appliance. That thing is huge. It's not just an ISO, it's an OVA, a collection of ISOs, and that OVA gets published out to the Artifactory, and it gets pulled down into our release builds. So we're small in terms of our size of our company, but we're complex in terms of our products. How are we doing for time?
All right.
Are we good?
Yep.
Or we're out of time? Cut it off? Say goodnight, Irene.
Yeah.
Thank you, everyone.